All right, good morning, everybody. It is 9:20. It's Friday. Yay for Friday. Sure wish you guys were here. It would make today's lesson so much easier. Again, what I'm going to do, if I even talk about it, is I'm going to today talk about a quadratic regression. So, a quadratic regression is going to be found, at least on my phone. I downloaded it. So I downloaded this little button here. It's quadratic. It's a regression line. I'm going to use this to come up with a parabola, quadratic instead of the linear. Okay. So to start off with, though, let's take a look. Okay. So what I did is I went on the track and I just timed a bunch of people to run the 400 because I like the 400, right? And I got different times. There's no doubt that you get to a certain age and you run at your fastest, and as you get old, you're slow again, right? So definitely a quadratic model. So let's make a scatter plot of this first, okay? So going ages all the way to 55, so maybe I'll go 10, 20, 30, 40, 50. So I'll go ahead and just put down those, and that's age. And then I'm going to do time over here in terms of seconds. And I got to get all the way up to like 130, right? So if I go 10, 20, 30, 40, 50. But I can squishy down my graph. I like to squish it down. So if I go squishy and start at 50, I like to squish my graph. 50, then I go 60, 70, 80, 90, 100, 110, 120. Yeah, that'll work. So 55, there's 60, 70, 80, 90, 100 seconds, 110, 120, and 130. Okay, that's going to fit pretty well for me. Now I'm going to graph these points. So I'm just going to do a rough scatter plot. Not have to be perfect, but I'm going to do a rough scatter plot. So let's see. I'm going to go ahead and put in age 10, ran about 123. So it's about there. Age 13, guesstimate age 13 is about a 105, a little bit faster because they're a little bit young, they're getting a little bit older. Age 15 runs at about a 68, a lot faster, right? 68. You can see that, as you get older and stronger like you guys are, you go faster. Age 22 is going to run at about 55. Okay. Right about there. Now we're starting to get a little bit older, and you're going to slow down unless you stay in shape. 61, and actually, if you stayed in shape, that's about the time you'd run your fastest. If that were truly your Olympians, right? These aren't Olympians. These are just people I pulled off the street. 41 is about 70, getting old. That's where it goes. Happens. And then 55, old man Bill. About 130, right? And I don't know, it'd probably kill me to run it now. So it kind of looks like a quadratic. I mean, if I tried to, just trying to fit a curve in kind of like that, maybe it's a quadratic. That's not a very good curve, so I'm going to let my calculator get a better curve, okay? So I like to use my quadratic regression, right? So let me clear all of these points. And I go to my table, and I'm going to add some points. In fact, I need 1, 2, 3, 4, 5, 6, 7 points. So 1, 2, 3, 4, 5, 6, 7 points, right? And I'm going to start putting them in. So I'm going to go 10 and 123. Again, you need some kind of a calculator. You can get this on your computer as well. 105. But if you put it in your app, find an app on your phone, it's so much better. 68, 22 and 55, 30 and 61, 41 and 70, right? 41 and 70, and finally 55 and 130. Okay, done. Now, it doesn't draw. It tried to draw it in, but it doesn't look very good, right? So then we're going to calculate the quadratic regression, and there it is. And then it kind of drew my line in there. Hits most points, but it doesn't hit them all. So we get this R value. That's my correlation coefficient. But first, let's write down the equation. So they write it backwards. I don't know why, but again, I did not make this calculus. So 0.14x squared minus an 8.65x plus about 185.8. Okay, that's the equation that my calculator got. They write it backwards. That's okay. I just rewrote it that way. Okay, so there's my equation. Come on. And then I want the correlation coefficient, which is about r squared. So r squared is about a 0.878. So it's not great. And we can see that it doesn't fit all of the points. The closer this is to 1, the more that these points would all line up on that curve. So it's not a bad fit. It's just not a great fit, okay? It's bad data, right? So I've got the equation. Here it is. Y equals 0.14x squared minus an 8.65x plus 185.8. Now, what's the fastest time? Well, the fastest time's got to be down here at the vertex, okay? Now here's the part you got to pay attention to. So the vertex, we have to use negative b over 2a. That'll give me the age. That'll give me the age for the fastest age. Probably around 18, 19, maybe 20, 21 would be the fastest age. So if I use my formula, I'm going to go negative b. That's b. So I'm going to go negative 8.65 divided by 2 times my a, which is my 0.14. I'm going to use my calculator to get the answer to find out the best age, okay? So I'm going to go clear that, and we'll go, if I can turn that volume up, there you go, maybe. I'll double negative, I'll just make it positive. 8.65 divided by 2 times 0.14. I get about 31 years old, okay? 30.9. So about 30.9 years old would run the fastest. And then it's all down here from there. And that's probably true about the Olympics anyway. You are at your best right around your early 30s, and then you start to get slow because you get old. Now, what is that time? Okay, if I want the time, I'm going to take this age, I'm going to plug it in, because y is going to be my time, so I'm going to plug it in. I'm going to go y equals 0.14 times this 30.9 squared minus my 8.65 times my 30.9, and then plus my 185.8. Okay, and I'll let my calculator do that. I like the answer button on my calculator. I think you guys are going to see this in a second. Let me slide this way up so you can see what I'm going to do. So I'm going to go, I've already got that as my last answer. So I'm going to go 0.41 parentheses answer. I like that answer button, so I don't have to retype that, right? Squared minus 8.65 times my answer, so I don't have to retype that, and then finally plus my 185.8. I get an answer of about 52, about a 52.2, which is not a bad time. Seconds. All right, so there it is. Homework is going to be out of your journal, and you're going to need to do a couple of things. I'm going to show you what I need to do, okay? And so first of all, they're going to say, is it quadratic? That one's definitely quadratic. That was linear. This one's neither. And this one is going to be quadratic as well. So you need to put these in your calculator and come up with it. Graph it, come up with it. Put it in your calculator, graph it, come up with the equation. Graph it. Since it's neither, there won't be an equation. I think it's exponential maybe. And then finally 12, graph it, right? and come up with the equation and give you the, and then finally on C, this is probably the extra, okay? Anyway, that's it. If you have any questions, give me a call, okay?